Okay, hello everyone. My name is Mehmet Onur Aybek. Today I'm going to talk about my digital design course project. I'm going to do it into two parts. In the first part, I'm going to explain the logic of my project on a paper. I'm going to explain how it works. And in the second part, I'm going to demonstrate it on a basis tree in the reality and how it works and what it does. Thank you. Let's start. Hello everyone again. Now I'm going to explain you the logic of my project, but I'm going to explain it in two different parts because there are two different logics which link each other, but I want to explain it in two different parts. First, in the beginning of my project, it asks for a password from the user, and when user enter a password and saves it with using a switch, my DC motor works. It works because it wants to say that yes, you save your password, but you didn't erase it from the 7-segment display, so anyone else can see what your password is. So when you open another switch, and your password erases from the 7-segment display, and the motor stops. So you can start to enter your password trying process. And my first part was about that. And the second part, it's about my project. As I said, it's the main part. You have, as you can see, you have 1, 2, 3, 4, 5, 6 trying chance to find what your password is. But it's like a game, so let's start from the beginning. First, you're entering a password, and you're open a switch, one of them. I'm going to show you in the other parts of my presentation. If your password is correct, in a 7-segment display, it writes open. If it's not, it writes fail. And in your second chance, you're entering another password or the same, but if it's correct, and when you open a switch, if it's correct, it writes open, it says open. But if it's not, it says failed. Again, there will be a third chance to know what your password is, because other parts are a little bit different. In your third chance, you're entering a password randomly. What do you want? If your password is correct, it opens it. It says open, but if it's not, in your third check, it says INVR. It means inverse. What inverse means? It means that, for example, your password is 0001. Now you need to write 1000 to open the system. For example, if it's 1234, you need to write 4321. Basically, it wants this. Let's continue from this part. Okay. When you enter a password, if it's correct, if it's the inverse form of your password, it says open. But if it's not, there will be actually two chances, but one process to open the system. If your inverse password is not correct, it says binary. It means BNRY. That means binary. And it asks for a binary number, and you need to know its decimal form to open the system. And there will be another switch. With using this switch, you will be able to see what the binary number is, and there will be 1110. It's predetermined because it's a basic project, so it's just like a game, so it's predetermined. And in your 5 chance, if you can enter 0014, means 14, it's equal to that in decimal to binary, it says open. If it's not, it says fail again, but you have one more chance to find what your password is. So again, you're switching on, you open the switch, and it says 0101, and it will be your last chance to know what your password is. And after that, if your input is 0005, which is equal to 0101 in decimal, it says open, but if it's not, it locks the system, and whatever you want after that moment, it will say lock, because your chances are over now. But there will be another switch which is switch 14. If you open it, the process is beginning again. I mean, you're initializing, you're erasing all the things you have done, and you can start again. Thank you for watching this part. Okay, let's start with the demonstration part of my project. But first, I want to introduce you what my components are. The basic, the fundamental, actually, the fundamental component that I've used is basis 3, and I programmed it with my project code in here, and it's my digital part, and I have an analog part. This is an H drive, and this is a DC motor. H drive helps us to convert the signal which comes from basis 3 to a proper signal to the DC motor to make it work. So if we send a signal which is 1 to the DC motor, it works. If we send the signal 0, it stops. And I used a DC power supply. It gives 7 volts to the H drive. Actually, H drive uses 2 inputs, which is one of them is 7 volts and one of them is 5 volts. 5 volts for making this device enable, and 7 volts for the DC motor. Okay, let's continue with the demo of my project. For example, let's pick up a password. It might be 1111. Okay, let's save it. When we save it, the motor begins working because it says that you need to erase the password from the 7-segment display. Now let's erase it. Now our password has saved and we see 0000, so we don't know what our password is. Okay, let's begin with the first case. Let's say if our password is correct. Let's enter it 111 and let's check it. And it's correct. We opened the system. Okay, when we open the switch, it erases all the things we done. It initializes the system. So let's erase it. Now let's pick up another password, which is okay 10000. It's enough. Let's save it. When we save it, as you see, the motor starts working, and it wants us from the erase this password from the 7-segment display. Let's erase it. Now our password is 1000. Now we can enter a wrong password, which is 0100, and let's open it. It says fail because your password is wrong. Okay, let's give the same input to the system again. It says fail again because our password is wrong again. Okay, let's continue the other thing. Now, if we open it again, we'll see the IMVR, as you see, because now it wants us from the inverse thing. Okay, let's do this. Okay, let's erase this because let's erase the password from the 7-segment display because it will be easier to write it again. What was our password? 1000. Let's write this. Now let's open it. And opened, as you can easily see. And let's initialize the password again. Okay, it will be another chance. I'm going to show another part of my project. Now let's use the same password. Okay, let's save it. Our motor works. Let's erase it from the 7-segment display. As you see, it stopped. And now let's pick up a wrong password, which is this one, is okay. And let's pick up another password. As you see, it failed. Let's do it again. It failed again. Okay, let's do it again. Okay, it will say fail because there was a bug over there. Okay, it's not important because I opened it twice in the same time. Okay, it's right inverse. It wrote inverse over there. Let's open it again. It will say binary. Now let's see the binary number. Okay, 1110. Let's open it. because it means 14. Our password has changed, so we need to enter 14, 0014 to the system to open it. Let's give it 0014 and let's open it. Yep, it has opened. Okay, and last time, now we will lock the system. Let's initialize it. Okay, let's pick up the password, which is 1000. Let's save it. Our motor has worked again. Now we'll erase it from the 7-segment display. Now, okay, we might check another thing, like this is enough. Let's open it. It failed. Now let's open it again. It failed. Let's open it again. It wants from the inverse number. Let's open it again. It's wrong. It says binary. Let's open another switch to see what the binary number is. Okay, we saw it. Close it. Check it again. It failed. Let's see another binary number, which will be 5. Yes, 0101. Okay, let's enter the wrong number. It needs to be 5, but we will enter 1438. Let's check it again. We lock the system. Whatever we do, it is locked, so we cannot do anything more. Okay, let's initialize the system again. Yes, basically it was my project, and I demonstrated it to you. I hope you liked it. Let's continue to the final thing, which is thanks. Thanks for watching. I hope you liked my project. See you next time.